Okay, Assalamualaikum. Okay, today we proceed with the confidence interval for beta 1 and also the test of concerning beta 1 and beta naught. Okay, so from the previous lesson, you have learned how to calculate the slope, how to find the regression line kan, for simple linear regression. So today, um, we focus on the slope and the intercept, the parameter of the slope and the intercept, and we want to calculate the confidence interval for this parameter. So why we are doing ataupun we are calculating the confidence interval for the slope, okay, it is to estimate the range. Kita nak tengok range, to estimate the range of y that will increase or decrease for each additional unit in x. Okay, so as you know, the slope adalah when we want to know when x increase, y will decrease or decrease. Increase or decrease by how many units, right? So sama juga. Kalau confidence interval, kita nak tengok dia punya range. To estimate the range of y that will increase or decrease for each additional unit in x. So I believe that you all semua dah familiar with this formula of the slope. Okay, I highlight sikit. This is the formula for the slope. So according to this formula, we need the value of slope, and we also need the standard deviation of the slope. Okay, and also the critical value from the t table with degree of freedom n-2 and 1 minus alpha over 2. Okay, so first of all, you need to calculate ataupun we need to determine the variance of the slope. And once we have the data, kita ada data column y, kita ada column x, then from there we can calculate the value of the parameter, and also we can calculate the variance of beta 1. Sebelum ni yang you belajar sebelum ni adalah estimation of the sigma square tu, itu adalah variance for the model. So sekarang ni kat sini kita nak gunakan standard deviation of slope. Okay, berbeza dia punya formula. Kalau MSE adalah sigma square, which is the variance of model. Okay, untuk nak dapatkan variance for slope, it is MSE divide dengan SXX. Betul tak? This part adalah SXX, which is summation of xi square minus summation x, all of that square, divide dengan n. Okay, so in order to use this formula, we need to calculate the variance of the slope first and then square root the value, and you akan dapat standard deviation of beta 1. Okay, let's say we consider this example from your textbook. Okay, management wishes an estimate of beta 1 with 95% confidence coefficient. Okay, so actually data daripada Toluca company ni ada dekat example in chapter 1 before this. Okay, so from there we have the value of beta 1 adalah 3.5702, and we need to calculate the variance of the slope in order to calculate the confidence interval for the slope. Okay, so using the value of MSE, you know how to calculate the value of MSE. Okay, divide dengan SXX, so you akan dapat the variance of slope. Then square root the value, you akan dapat standard deviation of the slope. Then you will apply the formula of the confidence interval for the slope. Jadi, so sekarang kat sini kita dah ada standard deviation of the slope, and then value 2.069 here adalah critical value from the T table. Okay, from your statistical table. So, kalau tengok dalam your textbook ni, dia buat T 0.975 sebab Kalau you tengok dekat belakang, dia punya table, T-table-nya adalah table less than. Okay, tapi dalam table merah you adalah table more than. Okay. So, kalau guna table merah, dia punya formula will be T alpha over 2. Saya cakap sini, bukan 1 minus alpha over 2. Okay. T alpha over 2 and minus 2. Dekat sini, kenapa dia jadi T1 minus alpha over 2? Sebab you punya table, T-table dekat belakang textbook ni adalah table less than. Tapi kalau gunakan table merah, table more than. But in exam nanti, you kena proceed dengan statistika table merah. But actually boleh juga kalau nak gunakan table lain yang you ada, since kita ODL, boleh gunakan table yang lain. Cuma you kena transform sikit lah dia punya formula of confidence interval ni. Okay, kalau nak guna table merah, kat sini will be T alpha over 2 and minus 2. So, you boleh check kalau guna table merah dan juga kalau guna table kat belakang ni, jawapannya sama, 2.069. Okay, so if we have all the value, so apply the formula, you akan dapat slope ini, dia punya range of y will increase. Kenapa increase? Sebab both of the right side and left side adalah positive. So, and then you need to interpret the value of the confidence interval for the slope. We can say that with confidence coefficient 0.95, ataupun we can say that we are 95% confidence that when we estimate that the mean number of work hours adalah Y, work hours kat sini adalah Y, mean of Y will increases. Kenapa increase? Sebab positive by somewhere between 2.85 and 4.29 hours. Okay, unit dia kena letak for each additional unit in the lot. Okay, so you kena put the unit dekat situ. Okay, we estimate that the mean of Y will increases or decreases, depends pada sign dekat sini, by somewhere between 2.85 and 4.29 hours. Kena letak unit for each additional unit in the lot. Okay. Kejap. Okay. So, either you find the value of the standard deviation for beta ni, whether you calculate using this formula, ataupun if the output SPSS is given, so you boleh ambil daripada situ sahaja. Okay, sorry, boleh ambil daripada standard deviation of the beta. Let's say here, okay, ini output kan, you akan dapat ni, this output. Pernah nampak kan this output? Okay, this output, nanti bila ada lab session, I akan tunjukkan how to get this output. But I believe that you all are familiar with this output in diploma level dulu. Okay, so daripada sini kita tengok standard deviation for beta. Ini standard deviation untuk beta naught, ini standard deviation untuk beta 1, 0.347. If output is given, so you just ambil daripada sini saja. And then kalau tengok ANOVA table ni pun ada value MSE. Okay, if not, if you is given the data, you boleh calculate. If it is the output SPSS is given, you can use the output sahaja. Okay, and also we can test the concerning of beta 1. We can test for the beta 1. Kenapa kita nak test untuk beta 1? Because we want to know whether there is a linear association between Y and X. Okay, whether or not there is a linear association between y, this part is y, okay, between y and x, between y and x. So untuk test for the beta 1 ni for the slope ada dua sebenarnya, two-sided test and one-sided test. So I explain dulu untuk two-sided test. So untuk two-sided test we are testing the beta 1 using the hypothesis of beta 1 equal to 0 and beta 1 not equal to 0 to see whether there is a linear association ataupun linear relationship between work hours between y and x. So from there, kalau beta 1 if hash not is rejected, so maksudnya if hash not is rejected, beta 1 equal to is rejected, so means that the slope, kita ada value slope. Okay, ada value slope, so means that the regression line ataupun regression equation tadi adalah linear. Okay, if beta 1 is 0, if we fail to reject hash not, we accept hash not, means that beta 1 equal to 0, then we can conclude that there is a no linear association between y and x. Kenapa macam tu? Sebab bila slope dia 0, so bila slope 0, tiada slope. Maksudnya dia punya akan ada horizontal line di origin sahaja. So daripada situ we can say that there is no linear association between y and x. So as usual, bila nak buat hypothesis testing, kena ada hash not, hash 1, and then the researcher need to determine the value of significance level. It depends pada researcher. And then kita kena ada test statistic. Okay, so for this one, it will be beta 1 divide dengan standard deviation of beta 1. So sebenarnya, kat sini, beta 1 minus the value of here. Okay, B1, the slope minus value of beta 1. Okay, but here in this case, sebab kita nak check the association between y and x, kita punya hypothesis testing beta 1 kita, whether it is 0 or not. So kat sini kita gantikan dengan 0. Sebab itulah ianya ada beta 1 sahaja. Beta 1 minus 0 sebenarnya. So sebab itulah dia akan jadi beta 1 sahaja. Okay. Alright, so the test statistic will be the slope divide dengan standard deviation of the slope. Okay, how about the decision rule? Okay, we will reject hash not if the test statistic t, the absolute value of the test statistic more than the critical value t table. So dekat sini sama macam tadi, if you are using the statistical table merah tu, it will be t alpha over 2 and minus 2. Right, kalau nak gunakan table kat belakang textbook ni, ianya 1 minus alpha over 2 and minus 2. So we will reject hash not if this. Okay, if we reject hash not if the absolute value of the test statistic more than the critical value. If not, kita fail to reject hash not. If we reject hash not, we can say that there is a linear relationship between y and x. Okay, for this example, the slope is 3.5703 and the standard deviation of the slope tadi 0.347. Okay, and then bila kira ni test statistik, dia akan dapat 10.29, which is more than the value from the table. So we can reject hash not. Okay, bila kita reject hash not, we can say that there is a linear association. Okay, there is a linear association between y and x. Okay, that is the way how you doing the test concerning the beta 1. if we want to know whether there is a linear association between y and x, whether the slope is significant or not. Okay, ada satu lagi situation, which is the one-sided test. When we wish to test whether or not the slope is positive. Okay, so kita test, dia punya hash 1 will be beta 1 more than 0. Kalau kita nak check, beta 1 is positive. So dia punya hash 1 will be beta 1 more than 0. Hash not will be beta 1 less than or equal to 0. Apa yang berbeza di sini adalah dia punya test statistik sama, which is slope divide dengan standard deviation of the slope. Cuma berbezanya adalah dekat decision rule, we reject hash not if the t statistic tiada lagi absolute kan, t statistic more than the critical value t 1 minus alpha, bukannya alpha over 2 sebab one-sided. Okay, remember here 1 minus alpha and minus 2 if we want to use the t table from this textbook. Kalau nak guna step table merah, dia akan jadi t alpha saja, t alpha and minus 2 untuk reject hash not. Okay, let's say for this example, we want to test whether the slope is positive or not. Okay, so apa ni? Ini tadi benda yang sama, test statistik 10.29. Cuma kita compare with the critical value yang berbeza di sini. It will be 0.95 sebab 1 minus 0.05. Ataupun kalau nak gunakan step table merah yang you ada, T 0.05, dia punya degree of freedom 23, you will get the same answer. So here, since the critical the test statistic more than the critical value, we will conclude hash not. So means that we conclude hash A ataupun hash 1. So we reject hash not. So our conclusion is the slope is positive. Okay, so boleh juga macam mana kalau you nak test whether the beta 1 is negative. So, kalau beta 1 is negative, kalau we want to test whether the beta 1 is negative, so di sini will be, dia punya hash 1 will be beta 1 less than 0 untuk hash 1. Beta 1 less than 0 untuk hash 1. Untuk hash not, beta 1 more than or equal to, sorry tak cantik sikit. Nanti saya akan beli pen. But now dia tak sampai lagi. Okay, beta 1 more than or equal to 0 untuk hash not. Beta 1 less than 0 untuk hash 1. If we want to test whether the slope is negative. Okay. So how about the decision rule? Dia akan jadi, we reject hash not if t statistic less than. Okay, reject hash not if t statistic less than the t 1 minus alpha. Kalau nak guna tabel merah, it will be t alpha saja dekat situ and minus 2. Sorry, cantik lah. Alpha and minus 2. Okay. Reject hash not bila t less than t1 minus alpha and minus 2. Okay, if reject hash not, we conclude that the slope is negative. Okay, that is the way how you test for test whether the slope is negative or positive. Okay, the next one adalah inference concerning the beta 1. Okay, so kalau baca kat sini, baca sikit, tulis There is only infrequent occasion when we wish to make inferences concerning beta 1. But usually we are interested in the slope. Kita nak tahu sebab daripada slope tu kita tahu kita punya regression line tu linear ataupun tidak. Sebab beta naught hanyalah dia punya intercept. So it is infrequent occasion saja, jarang berlaku. This occur when the scope of the model includes x equal to 0. Okay, kita akan gunakan bila scope of the model includes independent variable 0 sahaja. Maksudnya kan kita ada data y dengan x. Bila data x u tu ada include 0, barulah kita the value inference about the beta naught is important. If not, it is not very important to make the inference concerning the beta naught. Okay, so we are familiar with this formula untuk dapatkan beta naught, and then to test ataupun to find the confidence untuk for beta naught. Okay, untuk beta naught, this is the formula of confidence interval. Okay, sama macam beta 1, cuma berbezanya adalah the value sahaja. Here value beta naught, di sini adalah value standard deviation of beta naught. Sama juga dekat sini. If we use tiga tabel merah, so it will be on dekat sini alpha over 2 and minus 2. Okay, so we look at the example. Okay, according to the previous example for chapter 1, kita dah ada data x dan data y. So from there, we can calculate the value of beta naught and also the MSE. Okay, and then we are concerning how to find the value of the standard deviation for beta naught. So this is the formula that you need to memorize. Okay, it is MSE multiply 1 over sample size plus x bar square, the mean of x square, divide dengan x. Okay, kat sini x. Alright, so from the example given, the answer will be 685.34. Then square root the value, you akan dapat standard deviation for the intercept beta naught. And also, you also can find the value of the standard deviation for the slope tadi. Boleh gunakan output. Kalau ada output, you boleh ambil. You can get the value of the standard deviation for beta naught in the output attached. So just apply the formula, then you will get this value of this interval, confidence interval for beta naught. Okay. Okay, kalau tengok kat sini. Okay, dia kata, we caution again that this confidence interval does not necessarily provide meaningful information. For instance, it does not necessarily provide information about the setup cost, since we are not certain whether a linear regression model is appropriate when the scope of the model is extended to x equal to 0. So, means that dalam data yang asalnya x tu, dia punya value of variable x not in the range of 0 is not in the range of the value of x. So there is no meaningful information that we can interpret for this confidence interval. Okay. Alright. Itu sahaja untuk confidence interval for beta naught and beta 1. Okay, let's see the example. Let's see the example I just go through. This is the data. Actually data ni I dah mention before this in the previous example. Let's say this is the data that we have. Okay, so soalannya test the significance of the model. Kalau nak test untuk significance of the model, sebelum ni kita boleh gunakan F. Also, we boleh gunakan T. Boleh gunakan t-test, ini dipanggil t-test, dan juga boleh gunakan f-test. Before this, bila you ada ANOVA table, you boleh proceed dengan f-test to check the significance of the model. But also, we also can use the value, we can use the t-test to check the significance of the model by the hypothesis will be beta 1 equal to 0, beta 1 not equal to 0. Because of when beta 1 not equal to 0, we can say that there is a linear relationship between y and x. Okay, so we have this formula. We need to calculate this formula first in order to find the value of the standard deviation and apply in the test statistic here. Okay, and then you need to find ataupun compare it with the critical value from T table. So dekat sini saya buat alpha over 2 di sini sebab guna table merah. Okay, kat sini dia punya confidence interval, the degree of freedom is n minus 2 because of we deal dengan simple linear regression. Nanti later if we proceed with multiple linear regression, kat sini value of degree of freedom will be different. Okay, when compare with the critical value, so seems that the T statistic more than the critical value, so we reject #not. So lastly, we can conclude that there is a linear association between y and x, then the regression model is significant. Okay, next we can also find the confidence interval for the mean of y when the lot size increased by 1 unit. Okay, apply this formula. So also here we need the value of standard deviation for the slope. Okay, so apply this formula, then you will get this two value. So we can say that we are 95% confident that when the x increase by 1 unit, ini adalah value x. When the x increase by 1 unit, the mean for y will increase between these two value. Ataupun kena letak kat sini tu, kena letak tertinggal kat sini, kena letak dia punya unit which is hours. Okay, let's say here nak cari confidence interval untuk beta not pula, so we apply this formula. Once you need to get the value of the standard deviation for beta not, then apply this formula. So apa yang boleh you interpret kat sini, we are 90%, sebab dia nak kat sini 90%. So we are 90% confidence that when the lot size is 0, lot size ni adalah x. When x is 0, the mean of y will be between these two values. Okay, this is important untuk kita cari confidence interval for beta not if and only if you punya range of range of x is boleh kita kata zero, value of x0 tu berada dalam range of x.